times 5, 1 of 5. Remember that? I answered you the questions why we have to do this, right? And once this is okay, then we can say we can move on from here to there, right? Once the student understand what's going on, then we can move on this for procedure. If not, we have to go back to conceptual understanding. Why? Right? So therefore, we're gonna take a numerator times the numerator, denominator times denominator, and we get a 7 out of 40. Final answer, yes or no? Yeah, final answer is we cannot, no common factor, so we cannot reduce anything. That would be the final answer. Okay. Number 7. Percentage problem. Well, I think so. Percentage problem. A lot of people make a mistake for this problem. All right. How many of this percent of 80 is equal 20? All right. Now, one way we can do for this, method 1. Is you want to say, how many percent of, that means divide or times. Divide or times. Oh, that means the times 80, which is equal to 20. Alright. Now how many percent? That means a known number, how many out of 100 times 80 is equal to 20. Are you with me for here for the writing like this? Yes or no? Alright. And then actually this is what? Numerator times the numerator, so therefore 80 out of 1. So numerator times the numerator, denominator times the denominator. So therefore, which is equal to 20. Is that clear? So therefore, we have 80, a box times 80 over 100, which is equal to 20 over 1. So therefore, we can cross and multiply, right? Right? We can cross multiply. So we can cross multiply because of what? Equivalent fraction. Equivalent fraction, right? So now we have 80 times a box is equal to 2,000. Are you with me for this? Now what should we find in our box? Divided by how many? Divided by 80, yes. Divided by 80. And then the box is equal how many? You take a 2,000 divided by 80. So therefore, you should be able to get 25. Now, in elementary school, we say a known number, a box, right? And then in the middle school, we change this into what? X and X. And this is X. Is that right? In the middle school, then we're gonna change this one as X, and this is X. In the middle school, we're gonna change this as X. In the middle school, we're gonna change this as X. So this X is equal to 55. Does that make sense? Right. So basically, this is when we say what percent of 80 equal to 20. That means what percent times 80 is equal to 20. Does that make sense? All right, method 1, okay. Now, can we have another way to do it? Yes. I think I want to do number 9. All the percentage problem I want to work together, okay? Now, problem number 9, 80% of how many equal 160, right? Right? then we can use the method one. We can use the method one. So we have 80% times, right? How many is equal 160? So 80%, 80 or 100 times a unknown number, which is 160. We can do the set it up like this, right? Right? So therefore, we still can figure out 80 bucks on 100 is equal 160. And 160, actually 60 over 1, right? Can we cross multiply, yes or no? Or cross multiply. Now we cross multiply, so this time we got an 80 bucks equal 1600 or 16,000. 160 times 100, right? 160 times 100. So we got 16,000, right? Now divided by 80, how much we get? The bucks is equal to 200. Does it make sense to you for how we get this problem? This is a method one. This is the most of traditional method we will do in the class. Okay. Do we have another one? Another way to do this? Yes, we can do the other way. Alright, so now method two. Method two to doing this problem. Right. So we will do the segment, all right? This is a hole, right? And this is another hole, right? And this is a hole, right? And then can we say a hole is equal how many percent for this, right? So if a percent, we go in here. Then the number will go in here. Or you want to say money, we can go in here, right? Number, okay? Are we ready? Take your color pencil. Let's find it out. Percent. 100% is equal this much. Does it make sense to you for 100%? Now tell me what's the 80%? 80%, this is the 0%, right? 80% is about right here. Is that right? So we have 80. 80% is right here. Are you with me for 80% for this? Now 80% of what? Of what is equal 160, right? So 80% is 160, is that right? This is 160, are you with me? Right? Because 80% of what number? A big hole, right? And this is a pop, right? And then actually we got 160, the number is 160, right? And then next, we're gonna find a hole, right? Which is this number. This number actually is what we're looking for. Are you with me for the how we compare the segment? So this is whatever percent, we'll put our percent in. And then this is a number, right? Put our number. Alright? So now, if this is a picture makes sense to you, can we say 80 over 80 over 160 is equal 100 over x? Yes or no? Proportional reason. Right? This is with visually. This is not visually. Alright? This is just by, traditional method, just give you the rule of times, right? Something like that, right? But this is give you pictures, if this is this, And how much is 100% of this? Because this will be a whole. Is that right? So therefore, we have 80x, which is equal, all right, 160 times 100. Again, we got the 16,000 again. Is that right? So divided by 80. Divided by 80. So x is equal to 200. Now wait a minute. Is a 200 make sense? 200 makes sense? 200 is 100. 200 is 100%, right? 160, 80%. Make sense? Yes. We always double check. In your mind, once you arrive at the answer, we always double check the quantity makes sense or not, right? Now, if I got an answer like I get a 500, right? 500 for this. Then 80% is 160. Then you can mentally calculate, no, 500 is much, 160, 80%, no, that must something wrong, right? And you have to go back to calculate, recalculate, double check your answer is correct. Now here's 200, 160, yes, makes sense, 80%. Is that clear? What else we have percentage problem? Okay. This is another way I come up with, okay? This is called, this is the second method, and then number 3. Method 3. Method 3, okay? Now method 3 is the method. Who come up with? I come up with, right? After this teaching, in the past, I have a lot of students, they prefer number 3 because they use my method. The one I create, okay? And maybe one day you can create to helping people, okay? There's nothing here is shown on the textbook, okay? When I say it, and when I do this, it always work, okay? I will just basically label it. If I have a problem like this, I will just label it, okay? 80%. It is part or whole? Part, right? Okay, part. All right? Now how about this one? 80% of something. This is a whole or part? Whole. All right? Now 160 is a part of whole. Part, very good. Yeah. So part of the whole is a part. Makes sense. Is that right? So what we're gonna find? We're gonna find how many whole, right? So you label it. You have a student to label it. So we have a part of the whole and still part, right? All right. So now I will say part, whole, whole. Part over part is equal whole over whole. Part, whole, whole. Part, and whole. Alright? Not part. No. Not whole. Whole would be a center course. So just whole, okay? So part over part is 1. Whole over whole is 1, right? Now can we fill in this? This is called proportional reasoning. Now part, and we fill in part is 80%, makes sense to you? Right? And then part, do we have a part? for the number? 160 makes sense to you? Do we have a whole? Whole, how many percent? 100%, put 100 there. And the number whole, we don't know. Can we put our x, yes or no? Now, can we cross multiply again? Because equality. It is, the equivalent fraction, okay? Now, cross multiply, see what happens. We got 80x, 160 times 100. 80x is equal 16,000. Is that right? Divided by 80. Divided by 80. And we still get x is equal to 100. Does it make sense to you? So now you have a 3 different methods can do, right? Can want to do one method 1. If you like to make method 1, go ahead. Or you like a method 2 with a visual representation, go ahead. Or you like a papahoho, make things easier. Does that make sense to you? Or you can have 3 different ways you can find, okay? Now, number 8. Now, what's the first thing we have to do to mix number? We're gonna change this into what? We're gonna change this into what? Improper fraction, right? Improper fraction. So we change this into improper fraction. This is 5, 2 times 5 plus 1, which is 11. Is that right? Then we're gonna change this into improper fraction. 4 times 3 plus 1. We got a 13 there. Then next 11 out of 5. Then we can flip, right? After you introduce the conceptual understanding, then we can flip, right? If not, then we have to go back to conceptual understanding, right? We cannot always have a mystery for students, okay? If a problem, if don't understand, then we have to go back, right? If this is okay, then we move on. And then therefore, we have 11 times 3, 33. 5 times 13, 65. Final answer, yes or no? We have to check. Final answer. Can it divide by 11? No. Divide by 3? No. Nothing we can reduce? Final answer. Number 8, number 9. Oh, we did a number 9, right? Number 10. Again, what should we do for this? We're gonna change this into what? Improper fraction again, right? So actually, we're gonna change this into improper fraction. 2 times 4, 8. 8 plus 3, how many? 11. 11 times 3. So therefore, 33 over 4, right? And then we're gonna change this into means number, which is a and then 1/4. Do you have any question for our 10? Right. Number 11. Number 11, write a fraction name for 0.225. So we're gonna change this into what? Fraction, right? And you have to, all the problems, final answer has to be what? Reduced fraction, right? You cannot have a fraction without reduced fraction. Otherwise, so many different answers. If this is one answer is 1/2, and you got a 2/4, and you got a 6/12, there's no answer. Which one is the correct answer? Reduced fraction is the answer, right? It's our final answer. Yeah, this is the answer, but this is not final answer. Clear? So that's why we have to find the reduced fraction. Now 0.225, so I'm gonna write it down. 225 first, okay? Finding out, right? 225. Write it down, 225 first. And what's next? We count how many 0, okay? Place value. 1, 0, 2, 0, 3, 0, right? So therefore 1, 1, 0, 2, 0, and 3, 0. This is also a testing of your understanding of place value. Right? So 2, 2, 5 all over 1,000. Are we done yet? No. How should we do? We're gonna reduce, right? We're gonna reduce this. And we're gonna reduce this. How should we reduce this? This is called prime factorization method, right? 225 divided by 5, how many? You get a 45. Right? Can we find another prime number divided by 5 again? Yes or no? And then we got a 9. Well, 9 actually is a 3 and 3. So do we have a prime? Prime, right? We all have prime number. Why we have to find prime number? Because the numerator and denominator we have same prime number, then therefore we can cancel. Right? So we can rewrite this for the numerator is 5 times 5 times 3 and 3. What about 1,000? Divided by 5. Divided by 5 again. 40. Divided by 5 again. 8. Divided by 2, right? 4. Divided by 2. So now we have 5, 5, 5, 2, 2, 2. 5, 5, 5. 2, 2, and 2, right? Now next, the numerator and then denominator, we can cancel by the same number. Can we cancel 5, yes or no? Reduce. Can we reduce this? Yes. Can we reduce anything for 3? No, we keep 3. Can we reduce anything for there? No, nothing we can reduce. So therefore, this will be 9 for the numerator. And then you have to times it together. Okay. This is called the, so the final answer 9 over 4. Okay. All right, next problem. Problem 12. Problem 12. $610 times 2.3. Now, remember when you did this problem at I would say like elementary or middle school, right? Then the teacher will ask you to write it down 0.6, 2.3 like this, yes or no? Right? And what's next step for teacher? The teacher will ask you, you just completely ignore the decimal point, right? You can completely ignore the decimal point. So you take a 3 times A, you got 18 like this, right? And you get 2 times, you got 3 times A is 18. And then next, you get 2 times 6, you got 12, right? This is how the procedure is, right? And then you got 8 like this, you got 3 like this, you got 1 like this. Is that right? And then the teacher says, after that, you are counting how many the decimal point are there, right? And that's the 1, that's the 2, right? So therefore, the decimal point to the left or to the right? To the left or to the right? To the left. If to the right, that means the number getting bigger, right? So that's why we're gonna count it now how many decimal point and 1 and 2, and then therefore 1 and 2. So find it 1 and 2. This is 1 and 2. So you count in to the left for 2, right? So therefore you got 1.38, right? This is a procedure. But why? Why we have to do this? Why we have to move the decimal point? Why is important? Why is crucial? Alright? Why we have to move from here to there? And it's important to answer why, okay? Now before, students learn the decimal multiplication like this, and I assume they already know the fraction, right? They might know fraction, and next they will learn the decimal, right? So, in order to answer the question why, 610, can we say 6 out of 10, yes or no? Right? 2.3 actually is what? 2 is what? 2.3 is 2 and 3, 10, yes or no? This is a connect to fraction, right? Then next, they might know, before they're doing this, they might know this. We have to change this into what? Change this into a mixed number, change it into improper fraction. 2 times 10 plus 3, so therefore we got a 23 for this, right? And this is a 10, right? And therefore, 6 times 23, 10 times 10, right? Okay, put on your classmates, please. When teachers say, ignore the decimal point, right? That means it's right here, 6 times 23. So that's why we take 6 times 23. Are you clear with this? When the teacher say ignore the decimal point, right? Actually, you are not taking care of decimal point. Actually, take a whole number times the 23. Or take a 23 times 6, right? Is that clear? Now, then the teacher say, okay, you go ahead and multiply, we'll ignore the decimal point. This is what we're doing for ignore decimal point. So that's why we got 138, is that right? And the bottom, which is a denominator, 10 times 10 will be 100. Alright? 130 divided by 100, right? So when next, the teacher, therefore we got 138 like this, right? Then next, the teacher say, oh, you gotta move the decimal point to the left or to the right? To the left, for how many? 2. Right? The 1, because we count 1 and count 2. Or count 1 and count 2. What does this mean? That means we divide it by 100. See? That means we divide by 100. See? If we divide it by 10, we're right here. Right? If we divide it by 100, we're right there. Right? If we divide it by 1,000, we're right here, right? But in this case, it's not divided by 1,000. So therefore, we are not going far to 1,000. We divide it by 100. This is the reason why. Because 130A divided by 100. That's why we answer the question, why we have to move the decimal point. Is that clear? Right? This is why we answer the kids, children, why we have to move the decimal point, right? All the things have to connect to the things they learned before, previous knowledge. Okay? Alright, number 13. The next time I ask you why we have to move the decimal point, can you answer? Like this. Number 13, -7 minus -8. So for the integer operation problem, you know, I would make a difference for this. I think I will rewrite because minus, plus, negative, positive, right? Will always confuse, right? And operation, right? So therefore, I think you know, in the past, you know, we do that like this. This is not good writing. This is not good writing. This is horrible writing. Why I say so? Because you confuse the addition and the integer, right? Now what should we do? What is the better writing? The better writing is like this. -7 right here, and then minus -8. That would be better. Because this mean -7. This mean -8. This mean operation, right? So we take a net minus a negative, which is positive. -7 positive, right? So therefore, we have a positive 1. (13, 14, problem 14, 1 fifth times negative 89. So there's 1 fifth times negative 89 over 1, is that right? So therefore, we have negative 89 over 5, yes or no? Then we have to change this into mixed numbers, 17 and 4, 5. If no problem, I will just move up, right? If there's a lot of conceptual understanding, you know, and then I have to spend more time. 4 times -8, which is -32. Okay. 16, I think that I answer you the question why we have to find the common denominator, right? Now this time you look this problem is a different, right? Because you have a conceptual understanding, right? And we have the 7 and 6. Why? Because we need to make it as the same portion, right? So we have to make it as the same portion on the bottom, same portion on the bottom. So therefore, we take a 6 times 7, we get a 42 for this. We say that's 42 for this, right? Now in order to make it as a 42, we have to take a 5 times how many? We have to take a 1 times how many? We have to take a 5 times 7, is that right? In order to make a 42 as same portion, in order to do the operation, so therefore we have to take this is how many?
6.
6. So therefore we have 35 or 42. From 6 over 42, and together 41 or 42, right? So each time, once you have more conceptual understanding, and then you look at this problem, it's different, right? And you can make a picture and tell a story, and tell students what's going on. 16 and 17. We take a minus -9, which is positive a minus -9. So therefore, we have a plus 9, which is equal to 17, right? Then next, now 18. Oh, we learned so many different ways to do it. This, right? Do you like a traditional way? Do you like how about we do lattice this time? Okay. How about we do lattice this time? So we have 15, 1 and 5 there. right? Oh, nice. And then we have 1 and 3 right here, right? We can do differently, right? So therefore, we have 0, 5, 15. Remember that? We talked about this one. Each digit they have a home. Remember that? Right? And then this is 3 times 1, 0, 3. So that'll be 5. 5 plus 3 plus 1, 9. 0, 1, and 0, 1. Answer is 195. Right? Do the lattice method, you know, or you want to do the traditional method, right? It's up to you. So, but I think so, you know, once you have more methods, that is a benefit for you guys, right? And next, number 19, which is larger? Negative 9 or negative 10? Negative 9 or negative 10? Which one is larger? Negative 9, right? That's the kind of number line problem, right? Okay, 18, then 20. 8 divided by how many is equal to 24? Remember, we also talk about similar problem like this, right? I have 8 pizza, right? And I want to share how many people. Each people got how many portions, how many people I can share, right? Then in this problem, look. Oh, number, small. What number is big? Then this number has to be fraction, right? Sometimes fraction divided fraction number, right? Yes, it has to be fraction. Let's find it out. Is it a fraction or no? Can we say 8 divided by how many? Can we say 8 divided by a number like this is equal to 24? Yes or no? Right? Because last time we talked about if we have 3 divided by 2, can we get 3 over 2? Yes or no? 4 divided by 5 is equal to 4 over 5. Yes or no? And same as this one, right? Then can we cross multiply for this? Can we cross multiply for this? And this is 24x is equal 8. Both divided by how many?
24.
24 divided by 24, 8 is equal 8 out of 24, which is equal how many?
1/3.
1/3. Oh, yes. Divided by 1/3, right? The 24, right? Well, we ended up here for today, okay? And then tomorrow we'll continue, right?